As urban landscapes expand, consulting engineers and architects are at the forefront of designing efficient, sustainable, and high-performing buildings. One critical challenge is ensuring effective climate control without compromising energy efficiency. Traditional air conditioning systems, however, pose significant drawbacks. Air conditioning remains one of the largest energy consumers in commercial buildings. It increases operational costs, contributes to carbon emissions, and places excessive strain on the power grid. As professionals shaping the future of architecture and engineering, you need a solution that balances performance, efficiency, and sustainability. Introducing DRI's Indirect Direct Two-Stage Evaporative Cooling System, an advanced technology that provides exceptional cooling performance while significantly reducing energy consumption. But how does it work, and why is it the right choice for your next project? Let's explore its innovative mechanism. The cooling process begins with indirect evaporative cooling. Warm, dry outside air is drawn into the IDEC unit. Inside the high-efficiency Eco-Ice core, this air is divided into primary and secondary streams. Both air streams run in separate, dry and wet channels in the heat exchanger. The secondary stream is moistened and used to cool the dry stream of air through the heat exchanger, which facilitates the heat transfer from primary air to secondary air. Thus, the primary air, moving through dry channels, is cooled indirectly without any moisture addition. Thus, the indirect evaporative cooling process works effectively in both arid and humid climatic conditions. The now cooled and dry primary air enters the direct evaporative cooling stage. Here, it passes through specially designed wet cooling pads, where a second stage of natural evaporation brings the temperature down even further, still using 100% fresh air. The traditional evaporative cooling is limited by the wet bulb temperature of incoming air, but combining indirect and direct evaporative cooling processes can achieve even lower temperatures. In the first stage, the heat exchanger ensures the air is pre-cooled without adding moisture. This lowers the air temperature significantly before it enters the direct evaporative stage. Since the air is already colder before reaching the water-saturated pads, it undergoes a second cooling phase that pushes it below the wet bulb. This innovative approach enables IDEC systems to achieve sub-wet bulb temperatures, delivering cooler, more comfortable air than traditional evaporative cooling methods. Finally, the cooled air is supplied into the building. The result is cool, filtered, and above all 100% fresh air, providing superior indoor comfort, especially in warm and tropical climates, without using harmful refrigerants or high energy. The IDEC system is equipped with a closed-loop water management system, which includes UV sterilization, TDS sensors, and SS304 water tanks. This ensures clean, efficient operation, minimizing water wastage and making it suitable for use in hospitals, clean rooms, and sensitive facilities. Smart sensors continuously monitor temperature and humidity, while integrated PLCs and VFDs adjust fan speeds and cooling output in real time. This adaptive control ensures peak performance, lower energy use, and enhanced indoor comfort throughout the year. IDEC systems are available in a wide range of capacities, including custom configurations up to 100,000 plus CFM. Whether for factories, data centers, schools, or shopping complexes, IDEC offers a scalable, low-maintenance cooling solution that delivers consistent results year after year. Let's take a real-world example. In a hot and dry climate like Riyadh, where summer temperatures can soar above 45 degrees Celsius, with a wet bulb temperature of around 18 to 20 degrees Celsius, traditional air conditioning consumes enormous energy to maintain comfort. However, an IDEC system can reduce the supply air temperature to nearly 15 to 17 degrees Celsius, that is 59 degrees Fahrenheit, well below the wet bulb temperature without relying on high-power refrigeration, significantly cutting energy costs. Now, consider a different climate like Dubai, which experiences both high temperatures and elevated humidity levels. During peak summer, outdoor temperatures can reach 45 to 50 degrees Celsius, with a max wet bulb temperature of around 25 to 30 degrees Celsius. Despite these challenging conditions, an IDEC system can still provide efficient cooling, reducing supply air temperatures to approximately 22 to 24 degrees Celsius. This represents a significant energy-saving alternative to traditional air conditioning systems while maintaining indoor comfort, even in humid climates. A key aspect of designing an effective cooling system is ensuring occupant comfort. OSHRE's Standard 55 sets the benchmark for thermal environmental conditions in buildings, defining acceptable temperature and humidity ranges for human comfort. IDEC systems align seamlessly with OSHRE's 55 by maintaining optimal indoor temperatures and humidity levels while using significantly less energy. For architects and engineers prioritizing sustainability, this system is a game changer. Compared to conventional air conditioning, it cuts electricity consumption by up to 80%, significantly reducing operating costs and the building's carbon footprint, all without compromising cooling performance. From commercial offices to industrial facilities and educational institutions, the Indirect Direct Evaporative Cooling System is redefining climate control. Its eco-friendly design aligns with green building standards and can contribute to LEED certifications, making it the ideal choice for forward-thinking engineers and architects. DRI's experience as a cutting-edge and leading company in air engineering business. As leaders in sustainable building design, you have the power to drive change. Upgrade to an advanced, energy-efficient cooling solution that meets the demands of modern architecture. These systems are free from harmful refrigerants, which have high global warming potential, and contribute to the greenhouse effect and climate change. Contact us today to explore how the Indirect Direct Evaporative Cooling System can enhance your next project. Together, let's build a cooler, greener future.